You guys. Okay. All right. Sounds good. Sounds good. Sounds good. All right. So let's do a little blast from the past real quick. All right. So, all right. So who could tell me how to do this? Exactly. I'm going to substitute x. So I have 5. And then in place of x, I'm going to put what? -1, right? So then now we just do the math on that, right? 5 times -1 is -5. So I have -5 minus 4. And -5 minus 4 is -9. That's it. Questions on this? Makes sense? So we're just substituting the value for the variable into the expression, little math, getting the answer. Right? Do they tell you that the value? Yeah, it'll always tell you the value that you're gonna substitute. Yeah. Tell you that. Yeah. Oh, like the instructions. Yeah, it'll always tell you like evaluate, solve, simplify. Yeah, yeah. It'll always give you that. All right, a little bit more complicated. Tell me how to do this. I have 3x minus 2y when x is equal to 4 and y is equal to -3. Right. I'm going to substitute that. So I have 3 times what? Good. And then what do I put next to the 2? Perfect, perfect, perfect. What should I do next after that? Exactly. Okay, so what's that? Like 12, I think. And then what's next? Perfect. Good. Now what do I get? Perfect. And then 12 plus 6 is perfect. That's great. Any questions on this from anybody? You good? All right. Let's try another one. So in this question, right, I want to solve for y. So what's my first step? So am I subtracting 8 from 8 or 20 from 20? Which one? From which scenario? So you want me to subtract 20 on both sides? Okay. It's not what I would do, but I'll follow you. I would have moved the 8 over because I'm trying to solve for y. That's my goal. I want y by itself. The thing that you're solving for is the thing that you don't touch. You touch everything else. Okay. All right, so you want to move the 8 to the other side. All right. So I'm going to subtract 8 from over here. Remember, what I do to one side of the equation, I have to do to the other side of the equation. So I'm going to subtract 8 from over here. So now what do I have? I have negative 3y is equal to, what's that, like 12 maybe?
Yeah.
And what do I do after that? Perfect, right? Divide by negative 3, whatever's in front of the variable. But remember, I got to be fair. When I do the one side of the equation, I have to do the other side of the equation. So divide by negative 3. Go ahead.
For me, you division and multiplication to equalize sides,
Mm-hmm.
does it only apply to the one number or do you have to apply to everything?
Like if I had like if I had like 2x plus 3 and then I was doing the multiplication.
Yeah.
Yeah. So yeah, you have to distribute it to everything.
The one number,
Yeah.
you have like
Mhm.
x plus b and you have to have like two and then parentheses
Yeah.
x plus b. And
So it would be like 2 times x plus 2 times b. So just distribute it. Yeah.
class.
Yeah. Yeah. Don't worry, there'll be other examples coming up like that. Yeah. You're gonna see it actually in this lesson. So this cancels out. So I have just y is equal to, what's that? Like -4, right? And then that's it. All right. Any questions on this? Anybody? Good? All right. So I gotta build the vocabulary a little bit, and then we'll get into an example of what we're doing. All right. So here's the idea. We're gonna be graphing linear equations by plotting points. All right. Excuse me. Sorry about that. It's a new topic. Yeah. So we're going to graph a linear equation by plotting points, right? So there are several methods that could be used to graph a linear equation. The first method we will use is called plotting points, right? So, or point plotting method, whatever, right? So we find 3 points whose coordinates are solutions to the equation and then plot them in a rectangular coordinate system, the X and Y plane, right? And then by connecting these points, we'll form a line, right? And we have the graph of a linear equation, right? Not too complicated, kind of simple. Let's look at it. So here's an example real quick. We're gonna do this together. So we want to graph a linear equation by plotting points, right? So I have what? Y equals 2x plus 1, right? That's my equation. What I want to do is I want to create like a table of values. So real nice and simple. Table of values, you're gonna have some X inputs and some Y outputs, right? The Y outputs are the outputs for the equation that you have here, right? Y equals 2x plus 1. So I could plug in whatever numbers I want for X. Negative 1,000, 1,000,000, 8.2, 3.9, whatever, right? I like to do the most simplest numbers possible, right? So here's my simplest numbers, right? These are my favorite. -1, 0, and 1. All right? Just keep it simple. There are some advantages to using higher numbers depending on if your slope, which is the term that's in front of the x, if your slope is a fraction, maybe you might want to use whatever the denominator of the slope is to plug that in. That will cancel out the whole fraction, make it easier to get the y value. That's just a strategy. But generally speaking, -1, 0, and 1. You can't go wrong with those. All right. Let's take a look at this, right? For -1. So I'm looking for y of -1. So what am I going to do? I'm literally just going to plug in -1 for x and then just do the math, right? 2 times -1 is -2 plus 1. And then -2 plus 1 is what? -1, right? That's it. Simple, right? Let's try another one, right? So I want to know what y of 0 is. So this is going to be 2 times 0 plus 1. Anything times 0, you know, is 0, right? So this becomes 0 plus 1. Very simply, that's 1. There we go. All right, last one, right? So I'm gonna do it over here. So I want y of 1, right? Pull it up right here so you can see it. So I want y of 1. So what am I gonna do? I'm just gonna plug in 1. That's it. So 2 times 1 plus 1. Let's do the math on that. 2 times 1 we know is 2 plus 1. Call that 3. That's it. Now, according to the instructions, we only need 2 points, but I gave you 3, right? The more the merrier, right? But to be completely like honest with you and fair, you only need 2 points. All right. After you get these points, you're gonna plot them on the Cartesian plane. All right. Let's take a look at that. I'm sorry. Hmm? I'm plugging in a value for x. So what I'm doing is I picked some x values. I just gave you my favorites, -1, 0, and 1, right? Um, and then I plugged them in for x and I got a y value out. So the answers that I got out, the y values, right? These things, those are all the y's that are in this column, right? And then the x values, I chose that. I could have chose anything. It didn't matter, right? But I wanted to choose something simple. Right. So now I want to plot this, right? You guys are familiar with the Cartesian plane, right? So this is the x-axis, the y-axis, right? And then remember to plot a point. I'm just going to make up something real quick and then erase it. So let's say that I wanted to plot the point 1, comma 1, right? Remember that a point is always x, comma y. So the x coordinate goes first. So I go across the x-axis and find 1. And then I go up to the y-axis and I find 1. And where the two meet, where they intersect right here, this is the point 1, comma 1. We remember how to do this, right? Just you have your x, you have your y, you plot it on the graph, and that's it. Questions on that part? Are we good? We're good? All right. So let me just erase this real quick. Let's get back to what we want to plot, right? So I'm going to plot these 3 points, right? My first point is what? Is -1, comma, -1, right? So let me put it right here. This is my first point. -1, comma, -1. My next point is what? 0, comma, 1. And the point after that is 1, comma, 3. Now I want to plot these points on the graph, right? So I'm just gonna count out 3 spaces real quick. This is 1, 2, this is 3. You know that the middle and the center, that's the origin, that's 0, right? This is -1, -2, -3. This is 1, this is 2, this is 3, this is -1. Sorry about that. -1, this is -2. This is -3. Okay. So I have my plane. As you know, the planes they keep extending out left and right and up and down. So I could put in more numbers, but just for this example, keep it simple, right? So I'm gonna use another color so it could pop a little bit, right? I have my first point is what? Is -1, comma, -1. So I go across the x-axis to -1. Bam. And then I go down, right, to where they intersect at -1. So here it is, right? That's the point. -1, comma, -1. Next, I want to go across to the x-axis 0, go up to 1, right here. So this is the point, 0, comma, 1. Last, I want to go to where 1 and 3 intersect, right here. And this is the point, 1, comma, 3. Right? After you have those 3 points, I need you to just draw a line through them. So like this.
No. Is it? Wait. Never mind.
Okay. And that's it. That's the whole the whole mystery, the whole shebang. Is there any questions on this from anybody? I didn't need to do 3 points again. I could have just done 2, but it's just fun to do that. Go ahead.
Um, I need, much points, yes.
You need at least 2.
For every question.
Yeah, for whenever it's a linear equation like this, I'm making a line, I need at least 2. The more you give though, the better the picture. But I need at least 2. Yeah. If you guys are doing it on paper, maybe you might want to use a ruler to help you, especially if you have graph paper, right? Um Back in the day, what I used to do, like, like how Alex was asking about the ID. So I actually used to take my ID and then I used to use that as my edge. And that's how I made my lines, you know? But okay, would you guys like to try one? Okay,
Yeah.
okay. So the end result is I'm looking for a graph like this, right? I highly recommend you make a table of values. That's how you show your work for doing this, right? I recommend you use my points, but if you want to use other points, that's totally fine as well. My X inputs, that's what I meant, by the way. Okay. Everybody's good? All right, let's take a look. So you want to graph this equation by plotting some points. All right. Now, me personally, I love my, let me change that color real quick. I love my 1 and 0. -1's not bad either, but I really love these. -1, 0, and 1. Keep it simple. All right. So that being said, right, what's my y value is going to be? Let's plug it in. All right. So if I want y of -1, what am I doing? I'm just plugging in -1 for x. Any random number. Doesn't matter. I just like -1, 0, and 1. But you can do whatever you want. Yeah. Huh? Because it's linear, yeah. No, you make it up. Yeah, you could choose whatever numbers you want. I'm just choosing 1 and 0 because it's simple. Yeah, yeah, yeah. That's what I want on the test. You pick whatever you want. But I think to just keep it simple, you know? Yeah. So then this is what? -2 minus 3, which is what? -5. That's it. All right. How about y of 0? That becomes 2 times 0 minus 3, which is what? All right. 0 minus 3 is -3. Perfect. And then y of 1 is going to become 2 times 1 minus 3. Call that 2 minus 3. That becomes what? Not 1. 2 minus 3. -1. There we go. And that's it. Yeah, that's it. So my biggest number that I have is -5. So when I'm drawing my graph, right, I want to at least have 5, um, what's the right word that I'm looking for? Measurements on each axis, the left, the right, up and down, right? Let me show you what I mean because I feel like I might not have said that very well. What I'm trying to say is I want 5 to the left, to the right, up and down, right? So 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5, 1, 2, 3, 4, and 5, and then -1, -2, -3, -4, -5. Okay. Do I need all those points? No, but just to make it look even, and fit and everything, right? So anyway, what are my points? Remember, x comma y, right? That's a point. So I have -1, -5, right? I'm just copying from the list right here on the corner. I have 0, comma, -3, and then I have 1, comma, -1. That's it. And what I want to do, I just want to plot these points on the graph. That's it. So the first one is -1, comma, -5, right? So I'm going to go across the -1, go down to where -5 is. It's right here, right? After that, I have 0, -3. So I'm going to go across to the 0. Remember, 0 is on the y-axis. Go down to -3. There it is. And my next one is 1, -1. So I'm just going to go across the 1, go down to where -1 is. Boom. Right? And that's it. Always remember when you're graphing to label your points, right? So label your points. So this is going to be -1, comma, -5. This one is the 0, comma, -3. And this one is the 1, comma, -1. That's basically it. After that, just connect the dots. And that's your equation. Y equals 2x minus 3. Remember your labels. Something that I forgot to mention was this is the x-axis, this is the y-axis. No, huh?
You mentioned that.
Yeah. That's it. Go ahead. Yeah. Labels are important. Yeah. Yeah. Label your points. You have the line itself. You can write down the line next to it as well. And then the axis is, of course, is the x-axis, y-axis. So, any questions on this?
So the number,
Yeah, any number you want. Yeah.
like 2 4 5,
Yeah, that's fine. You could do that. Yeah.
you don't think.
Yeah. Yeah, go ahead. Yeah, the only time you wouldn't see me use -1, 0, and 1, like say the slope was a fraction. Fractions are a little bit complicated, especially when you're dealing with whole numbers and stuff. So in that scenario, I might multiply by whatever the denominator of the fraction is. So that might make it just a little bit easier. Positive and negative of that denominator. That's the 2 points right there.
We got a problem.
Yeah. So this right here, this is actually just one technique where we're pretty much going to be doing graphing all day, but we're going to go through different techniques that you could use to get a graph, right? So this is one technique. You make a table of values, you plug in a couple of points, right? You only need two. I like to do three, right? And then you just graph it. All right. All right. Let me know when you're good. Okay, no problem, no problem.
So we always gotta put that first on the.
Which
Five
one?
people, whatever.
Oh, yeah, 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 yeah.
So we gotta always put that, whatever you want.
Yeah, yeah, because you're trying to get the y values out. Like the x value is what you're making up, and the y value is the answer that you're trying to get out from the equation. Mhm. All right, you good? All right. So real quick, just want to give you guys some notes. How to do this. So how to graph a linear equation by plotting points. Step one, you want to find 3 points whose coordinates are solutions to the equation. Organize them in a table, right? Step two, you want to plot the points in a rectangular coordinate system. Check that the points line up. If they do not line up, carefully check your work, right? So all those points should like they should appear as if they're on a straight line, you know? If they don't, then something went wrong. Like if one point is like all the way over here and the rest of them are down here, something went wrong with that. All right. Step three, draw the line through the 3 points and extend the lines to fill the grid and put arrows on both ends of the line. So the reason why the arrows are there, because we want to show that this line is continuously going in both directions. All right. Questions on this, anybody? Okay. If you guys want to take a picture, go ahead. Just make it a special note. So it is true that it takes 2 points to determine a line, but it is good habit to use three. If you only plot 2 points and one is incorrect, you can still draw a line, but it will not represent the solutions to the equation. So it will be the wrong line. So what they're trying to say is that if you only use 2 points and you did the math wrong on one of the points, right, you won't be able to tell that like the line is not right. It's when you do more points that you can say, okay, this 1 point over here, I must have did something wrong with that because all of them are appearing to line up here, you know? Um, if you use 3 points and one is incorrect, the point will not line up. This tells you something is wrong and you need to check your work, right? So look at the difference. So here's an example right here, right? You see how these 3 points, they fall on the line? That's what I want to happen. They fall on the line. But you see over here how these this it looks like there's a line either here or there's a line going this way, or there's a line going this way, right? The points don't line up. So because they don't line up, something went wrong. We don't know what, but something went wrong. All right. Just want to make a special note real quick. Mhm. So when an equation includes a fraction as the coefficient of x, we can still substitute any number in for x, but arithmetic is easier if we make good choices for the value of x. This way, we will avoid, excuse me, fractional answers which are hard to graph precisely. I could graph 1 comma 3, but it's kind of hard for me to graph 4/3 comma 8. Like where is 4/3? You know, so if we can, it's best to keep those whole numbers, right? If we can. Let me show you. So similar question as before, right? I want to graph this equation, but I have a fraction for my slope. That's my issue, right? How do you graph a half? I mean, I know half is in between two numbers, but the problem is in between two numbers, like so it's a little bit harder to graph. So for me, here's what I'm gonna do. I have the wrong color. 1 second, 1 second, 1 second. All right. For me, this is what I'm gonna do. All right. I look at what is on the bottom of the fraction, the denominator, right? And that's what I'm going to plug in for x. So I'm going to plug in -2. Of course, I got to plug in 0. Zero is the OG, right? And then I got to plug in +2. That's it. And then just the same thing we are doing before. So I want to do what is y of -2. That's what? 1/2 times -2 plus 3. These will cancel out, leaving just -1 plus 3. And the answer is +2. Simple, right? Go ahead. The -2 on the y. Like I chose it. That's the x value that I chose right here. Yeah. You could choose whatever you want, you know? Oh, this because that's what I'm plugging in for X. Yeah. We're gonna talk more about that later today actually. That's something called function notation. I'm gonna elaborate about that like more. But just know that I want to plug in -2 into the expression, so that's why, you know? But I know you're used to seeing it like this, where this just says y equals, and I'm saying I'm gonna plug in um x equals -2 for y, right? So that's another way of doing it, right? But the more common way that you will see it in the future is using function notation, where you plug it in, right? But we're gonna get to that. That's actually another topic for today as well. Right? Get this out. So I want to do y of 0 is equal to 1/2 times 0 plus 3. This is going to give me 0 plus 3. Call that 3. Right? And then same thing, right? I want to do y of +2. So this is going to be 1/2 times 2 plus 3. Let's call that 1 plus 3, which becomes what? 4. And that's it. Any questions on this? Excuse me. Any questions on this? Okay.
Wait, you could 0.0.
Yeah, I could have. The problem is that it would give me a fraction out, you know? So like if I do up here, let's say I plug in 1 right here, right? It's gonna become 1/2 plus 3. So 1/2 plus 3 is like 3.5. Like that's hard to graph, you know? But 2, 3, 4, that's simple, you know? I know exactly where those are. So once again, my biggest number that I have here is 4. So because of that, I'm going to make my graph up to 4, right?
Can you do another pattern?
Another fraction. Oh, you mean like another example with a fraction? Yeah, I got you. All right. So this is going to be 1, 2, 3, 4, -1, -2, -3, -4. This is going to be -1, -2, -3, -4. And this is going to be 1. Hold on, I made a mistake. Let me try it again. 1, 2, 3, and 4. All right. So now let me just scroll up. What are the points that I have? Remember that your points are always x comma y. And my points here are going to be what? -2 comma 2, 0 comma 3, and the last point, 2 comma 4. Now let's look at where they intersect that. So -2 comma 2 right here. Then I'm going to have 0 comma 3, which is right here. And then I have 2 comma 4, which is up here. And that's it. Remember to label those points as well. So we put those labels in now. This is -2 comma 2. This is 0 comma 3. And then this is 2 comma 4. Now, if you're wondering, like, why do I put the points first and then I label it like after? Why don't I label it with the point? I want to ensure that when I draw the line, the line doesn't go through the writing of the name of the point. So that's why I write it after, right? Just to make sure of that. But whatever you choose
So
is
wait,
good
why on the X side, why you chose -2, 0?
because it cancels out the fraction in the slope. All right. Because you see, the fraction is 1/2. So if I multiply 1/2 times 2, that just becomes 1, you know? Yeah. And after this, you already know, just make a line as best you can, no pressure. Right? And then this becomes what? Y equals, I don't even remember what this was. 1 second. 1/2 x plus 3. And that's it. Mhm. Where, how far? Okay.
So every time there's a fraction, you can put cancel it out.
Whatever the denominator of the fraction is. So say the fraction that was there was like 1/3 or 1/5. Let's make up something else, right?
It's like 7, 8.
All right, so 7/8, right? So I would plug in +8 and -8 because that will cancel out the fraction. So 7/8 times 8 is just 7 flat, and then 7/8 times -8 is just -7. So it makes it easier, with the whole numbers. Yeah, whatever's on the bottom of the fraction, and of course 0. I can't forget about 0. That's my friend right there. Yeah. All right, let me know when you're done, then I'm gonna put up an example for everybody to do. I'm sorry.
Oh, no.
Hmm. All right, we good? So I'll give you a couple of minutes. Try this one out. I don't, but I have another pencil if you want. If you want, just like leave them up here. I'll sharpen them during what you call it, the break. Yeah, that's no problem.
Inside, three, the.
Yeah, yeah. That's what I would actually choose.
every time
Mhm.
you make you make it feel like
Oh, it just becomes one. They cancel out. So 1/3 and 3 is like your make it to a fraction. 1/3 times 3/1. And then you just reduce. And it becomes one. You know? Mhm. All right, bear with me 1 second.
We're gonna go over the things in the back there, next week.
We've done all of these already, to be honest.
Yeah, I know.
Yeah.
Said there was,
Yeah. I mean, we're gonna review it for sure. But it's a catch 22 though, because I have stuff that I need to do today, you know? Yeah. Because the worst thing that I would want to happen is you have your test next week and we didn't finish all the topics, like because then that's gonna hurt your opportunity to test out. But I'm gonna come up with something like, yeah, don't worry, man, I got y'all.
it.
All right, just bear with me 1 second. I'm just reading something. I'll get back to y'all in a second. Or Fabricio, can you check them and make sure that they got this answer? I appreciate that, man.
Under off.
Five.
All right. All right. Take. So let's look back over this, right? As Alex was saying, we're gonna plug in 3, right? So I have I always do this. Wrong color. All right. I have my X and I have my Y, right? So I'm gonna plug in -3, 0, and 3. And the reason why I chose those numbers is because of the denominator in the fraction of the slope, right? So let's do it. I want to do y of -3. This is going to be 1/3 times -3 minus 1. Just to recap, right? This is actually 1/3 times -3/1, right? And remember, you reduce the fraction before you go through. So 3 goes into 3 once, 3 goes into -3, -1 times. So this becomes -1 minus 1, which is -2. And that's it. Let's do 0. This is going to become 1/3 times 0 minus 1. Let's call that 0 minus 1, which is just -1. Not too bad. Last but not least, I have y of 3, which is going to be 1/3 times 3 minus 1. And just to recap, this is 1/3 times 3/1 minus 1, reduce it, right? So this becomes what? 1 minus 1, 0. And that's it. If you had some other numbers, that's fine as well. All right? Yeah. Appreciate you. Yes, you're welcome. All right. If you had some other numbers, that's fine as well. So just graph it, nothing crazy. Now, I'm just looking at the set of numbers that I have here. I have up to 3, right? You can do the axis is out longer, but all I need to do is 3 to successfully get this. I think I'm going to go 4. So 1, 2, 3, and 4. And then -1, -2, -3, and -4. And then -1, -2, -3, -4, and then 1. Wait, hold on. See, I always make that mistake. 1, and then 2, and then 3, and then 4, right? So here's what we want to do, right? I want to get these points on this graph. All right. Let me just recap what my points are from the table. So my points, remember a point is x comma y, right? Are -3 comma -2. 1 second. Is 0 comma -1 and 3 comma 0. These are my points, right? Oh, I forgot to mention that this is the x-axis and then this is the y-axis. All right. Always want to put our labels. And then what do I want to do, right? I want to plot these points. So I have what? -3, -2, -3, -2 right here. Bam. I have, what's my next one? 0, -1. So come to 0, go to -1 right here. Boom. And then last one, 3 comma 0 right here. All right. Now, don't forget the labels. So this is -3, -2. This is 0, -1. And then this one is 3 comma 0. Right? After that, what do we want to do? We want to draw a line straight through it. Do your best. I'm not expecting a perfect line. Just do your best, right? You're supposed to pass through each point. This is me drawing a line without having a straight edge, you know? So this is the equation y equals 1/3 x minus 1. And that's it. All right. There we go. So is there any questions on this? Did everybody get this line? All right, we good? All right, so we're still talking about graphing lines. All right. But I have another situation that we're going to talk about right now. All right. So this is going to be graphing vertical and horizontal lines. So literally, I'm talking about a line that if it's vertical is literally just going straight up, just straight up. And another one that if I'm talking about horizontal lines, I mean a line that's going like straight across, right? There's no slope to these lines, right? So remember the other graphs that we had, there was like a little angle to them. There's no angle here. It's just a straight line across or a straight line up and down. All right.
Just
Mm-hmm.
variable.
Mm-hmm. Exactly. For both of those. Let's talk about it. So we're going to graph vertical and horizontal lines. So some linear equations have only one variable, right? They may have just an X or no Y or just a Y without an X. This changes how we make a table of values to get the points to plot, right? So let's consider the equation X equals -3, right? This equation has only one variable X, right? The equation says that X is always equal to -3. So its value does not depend on Y, no matter what is the value of Y. So the value of X is always -3, right? The secret, make your table of values and then you're good to go. That's the secret, right? So to make, right, a table of values, you write -3 for all of the X values, right? Then choose any value of Y. Since X does not depend on Y, you can choose any numbers you like. But to fit the points on a coordinate graph, we'll use 1, 2, and 3, right? So in this particular line, right, we're going to graph the line X equals -3, right? So X is -3 for every single point. So all I'm doing is I'm just plugging in some Y values to make the table, and I'm just going to graph it, right? So X is -3, -3, -3, and the Y could be whatever you want. In this case, 1, 2, 3. The point from each one is gonna be -3, comma 1, -3, comma 2, -3, comma 3. All right, that's your table of values for that. And then just to show you what that's gonna look like, here it is. All right. So you plot the points from the table and you connect them in a straight line, right? So here's our points: -3, comma 3, -3, comma 2, -3, comma 1. Those are our 3 points. The line goes straight through the x-axis at -3, and that's it. Right? Vertical line. Questions on this?
Question, the table for sigma, where you show your X and Y.
Yeah.
Is that required for credit for like showing your work?
Not really, but you should do it. You know? So put it like this, right? If you every professor is different, right? But if you show work and let's say that your answer is wrong, right? The professor could look at your work and then give you partial credit, towards your answer. Like, let's say, for example, you meant to write the number 8, but you accidentally wrote the number 3, for example, right? Like, they could see that and then say, all right, had this been the number 8, the answer would have been right. But because that one little mistake, it made the answer wrong, but all the other steps were right. So now they could give you a lot of partial credit because you knew what you were doing. It was just a little number error, you know? So like that's the reason why we like to show work, like to get that partial credit. I know some students, believe it or not, and this is gonna sound bad, but I'm gonna just be honest with y'all. They never answer the whole question right, but they knew what to do to get to the answer, right? They just didn't know how to execute it like effectively. So their whole test was wrong. The answers were wrong, but like the processes were spot on and they passed. You know, they didn't pass with 100, but they passed. You know, so partial credit is real. Like it's a good thing. It really is there to help you. You know. All right. Let's flip the script on this now, right? So we spoke about the vertical line. Let's talk about the horizontal line. So what if your equation has y but no x? Let's graph the equation y equals 4. This time the y value is a constant. So in this equation, y does not depend on x. We're going to fill in 4 for all of the y values in the table and then choose any values of x, and we'll use 0, 2, and 4 for the x coordinates, right? So all of our y's are 4 because we're going to graph the equation y equals 4, right? And we're choosing some values for x. In this case, 0, 2, and 4, right? Each one of these points are going to be 0, 4, 2, 4, 4, 4. You just plot them, connect the dots in a horizontal line, and that's it. Right. Exactly. For a horizontal line. Let me just show you what that looks like real quick. All right. So this is going to be our graph right here, right? So we have a horizontal line. It's passing through the y-axis at 4, right? And then we just plotted a couple points on it, and we just made it. Questions on this? Mm-hmm. It's clear? This makes sense? Okay.
So what if it's
Same thing. I'm going across the axis at a fraction, like answer. So let's say that I had y equals 3/4. Just making it up, right? It's gonna cross the y-axis at 3/4, and it's gonna be the same horizontal line. It's it. If it was for the x, same thing. Like if I wanted to graph x equals 1/2, like half, it's gonna pass the x-axis at positive half. It's going straight down, and that's it. You just pick whatever other numbers you want to make the coordinate complete, and you're good to go. Good. I just want to elaborate real quick before we try one. So vertical and horizontal lines. A vertical line is a graph of the equate of an equation of the form x is equal to a being some number. The line passes through the x-axis at a comma 0, whatever that number is, comma 0. A horizontal line is the graph of an equation of the form y equals b, right? Where the line passes through the y-axis at 0, comma b.
You have to show it a passing zero point.
Yeah, yeah, that's important to show. All right, let's do one together real quick. Okay. All right, go ahead.
That's the one.
Huh?
That's the only one.
Hmm. Yeah, that's all the definition. But let's try one together, right? Let's try one together. So all I want to do here is I just want to graph these. All right. So I'd appreciate it if you gave me a table of values. So I'm looking for A, for example. So X and Y. And then I know that my X is gonna be 2, so I'm gonna have 2, 2, 2. And then you just want to pick whatever Y's you want to pick, right? You already know what I'm gonna pick, right? -1, 0, and 1. That's my favorite. That was my trio right there. You know? And then you just graph it. Just like this. So this is going to be the x-axis. This is going to be the y-axis. I'm going for x equals 2, right? So 1, 2, right here. All you're going to do, just plot these points. Nothing crazy, right? Oh wait, hold on. I made a mistake. Wait, let me do this real quick. So this is going to be 1. This is -1. And you guys know that the origin is 0. So I'm just going to plot these points, right? So I have +1, 0, -1, just like that. Label them, right? This is, what's that? 2, comma, -1, 2, comma, 0, 2, comma, +1, right? And just give me the graph, just like that. And this is x equals 2. That's it. So kind of the same process as before, right? Give me the table of values, you plug in the points, you plot the points, connect the dots. That's it. Let's look at B. right? So again, I want to make a table of values. In this scenario for B, y is equal to -1. That means that all the y's are -1. And what I have to do is pick some x values. Which x values do you think I'm going to pick? My favorite. -1, 0, and 1. Simple. All right. And then after that, go straight to the graph. Yeah. Let's go straight to the graph. That's all we got to do. So all I need is, I don't even need to go far. All I need is 1, -1, -1, +1, etc. Right? So y equals -1, right? So, yep. So all I got to do is just plot these points. So I have -1, comma, -1. That's right here. Then I have 0, -1, which is right here. And I have +1, -1, which is right here. Then after that, give me the graph. Nothing crazy. Y equals -1. All right. Questions on this? Go ahead.
What are they preparing the,
Hmm. Yeah. They gave me A and B, and I just filled in the table of values and I plotted the points, and that was it. Will this make sense? Do you guys want to try one, or you feel like you get it? You get it? You get it too? You good? You good?
Yeah.
How about you, Jay? You good? Good. All right. So let's move on. This next one's part is kind of cool too, right? So we're gonna be finding the x and the y intercepts. All right. All right. So we're gonna find the x and the y intercepts. So every linear equation can be represented by a unique line that shows all the solutions of the equation. We have seen that when graphing a line and by plotting points, we could use any three solutions to the graph. This means that two people graphing the line might use different sets of 3 points, excuse me. At first glance, right, their two lines might appear to be the same since they would have different points labeled, but if all the work was done correctly, the lines should be exactly the same, right? One way to recognize that they are indeed the same line is to look at where the line crosses the x and the y axis. These points are called intercepts of a line, right? So an intercept of the line is where the graph is going to cross the x or the y axis. All right. Let me reiterate that. So intercept of a line is the points where a line crosses the x-axis and the y-axis, right? And they're called the intercepts of the line. So let's look at these graphs real quick. I'm looking at the first graph, right? You see this point right here? 3, 0. That's my x-intercept. It's where the graph is crossing the x-axis when y equals 0. Over here, this one, this is called my my y-intercept, right? It's where the graph will cross the y-axis when x equals 0. All right. Questions on this? All right. On the other graph, I have x-intercept as 4, 0. I have y-intercept as 0, -3. That's it. Any questions?
No,
No, these are slanted. What I'm looking for is I'm looking for the intercepts, the x-intercepts and the y-intercepts.
you know,
Yeah. So to find the x-intercept, you have to set the whole equation that they give you equal to 0. To find the y-intercept, you plug in 0 into the equation that they gave you, and then you get an answer out. Okay. Over here, what's my x-intercept? I'm looking at the first graph on the left. 5 what? 5, 0. That's what I want to hear. What is my y-intercept? Perfect. No,
the line, five,
exactly. That's all I'm asking for in these. What about this last graph? What's my x-intercept?
0,
0 what?
0, 0,
0, right? What's my x-intercept?
0,
Good. All right. This is possible. This kind of thing happens. So you know. Let's talk about it. So first, notice where each of these lines crosses the x-axis, right? Now, let's look at the points where these lines cross the y-axis, right? So line crosses the x-axis at 3, then you have the order appear 3, 0, 4, 0, etc., right? Then the line crosses the y-axis at another number, and your ordered pair is going to be 0, whatever the y-axis value was, right? That's it. So, question, do you see a pattern? So for each line, the y-coordinate of the point where the line crosses the x-axis is 0. The point where the line crosses the x-axis has the form a, 0, and it's called the x-intercept of a line. The x-intercept occurs when y is 0, right? So in each line, right, the x-coordinate of the point where the line crosses the y-axis is 0. The point where the line crosses the y-axis has the form 0, b, and is called the y-intercept of a number, right? So the y-intercept occurs when x is equal to 0. Questions on that? Make sense? I got you. So do you see a pattern? For each line, the y-coordinate of the point where the line crosses the x-axis is 0, right? The point where the line crosses the x-axis has the form a comma 0. So whatever number is crossing, comma 0. That is called the x-axis of the line, right? The x-intercept occurs when y is 0. In each line, the x-coordinate of the point where the line crosses the y-axis is 0, right? The point where the line crosses the y-axis has the form 0 comma b and is called the y-intercept of the line, right? So the y-intercept occurs when x is 0. That's important. And then that's it. Clicked on the wrong thing. 1 second. Quick recap. So the x and the y-intercept of a line, the x-intercept is the point a comma 0 where the line crosses the x-axis. The y-intercept is the point 0 comma b where the line crosses the y-axis. The x-intercept occurs when y is equal to 0, right? So this is your x-intercept. The y-intercept occurs when x is equal to 0. So this is your y-intercept. Questions on this? Clear? Go ahead.
The eight is a bad.
Random number, anything. Yeah, it doesn't matter. Yeah. Okay. This example is going to be a little bit hard because of the size of it. So basically, on these two graphs, I want you to tell me what is the x-intercept and what is the y-intercept. All right. This might be a little bit small, so if you guys want to like come over and point to it or just tell me from your seat, I'll take that. Let's do A, for example. What is the x-intercept? Okay, so I heard 0 comma 2. X-intercept, yeah. It's okay, I'll take it though. This was the y-intercept, 0 comma 2. What's the x-intercept? 4 comma 0, right? So remember that the points are always x comma y. So x always comes first, then y, right? All right, next graph. How about B? What do we think? X-intercept is what? Good. What is the y-intercept?
Zero.
Very good. And that's it. That's all done. I'll let you guys try one. Here you go. Here you go. So long story short, I want the x-intercept, I want the y-intercept.
Zero,
What is it?
0.
2 zeros? Let me see. So x-intercept is what? Like 0, 0? Oh, 2, 0. Got you. That's perfect. What's the y-intercept? 0 comma negative 2. Very good. 0 comma negative 2. Good. Questions on this? You guys good? I can move on? All right. So now we want to find the x and y intercepts from the equation of a line. So we're going to use the equation of a line to find the x-intercept of the line, which is when y is equal to 0, and we solve for x. Or we're going to use the y-intercept of a line when x is equal to 0, right, to solve for y. Okay, let's take a look. Let's try this out. Hmm? So in this example, I want two things. I want the x-intercept and I want the y-intercept, right? Now, to find the x-intercept, the x-intercept is where the graph crosses the x-axis when y equals 0. So what am I going to do here? I'm going to literally just plug in 0 for y. This is going to become 2x plus 0 is equal to 8, right? This is to find the x-intercept, by the way, right? Do the math on this. This becomes 2x equals 8. Divide by 2, divide by 2. This becomes x equals 4, right? So my x-intercept is what? It's going to be 4, comma, 0. Right? Questions on this? All right, let's get to the next part. So the next part says, I want to find the y-intercept. Why did I divide by 2? Because I want x by itself. I want to solve for x. Not distribute. Divide by 2 to get rid of it. And what you do to one side, you have to do to the other. Yeah. So now I want the y-intercept. Remember, the y-intercept is where the graph crosses the y-axis when x equals 0. So what do I do here? Plug in 0 for x. So this is going to become 2 times 0, right? Plus y equals 8. Yeah. Mm-hmm. Just plug in the zeros. So then this is going to become 0 plus y. So final answer, y is equal to 8. So what's my y-intercept? 0, comma 8. And that's it. So I have my x-intercept, I have my y-intercept. Go ahead. Yep. Yep. Just plug in the value and you get it. What do you mean? Put an x-intercept and a y-intercept? I'm always plugging in 0. Always. Yeah, but the answer that I find is the opposite of what I just plugged in. So if I plugged in for y, I'm getting back out an answer for x, right? And if I plug in the 0 for x, I'm getting an answer out for y. Right? That's it. All right, do we feel like we get this or y'all want to try one? Good? 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 All right. So let's take it up a notch. This is what I want to do. I want to graph a line using the intercepts, right? So to graph a linear equation by plotting points, you need to find 3 points whose coordinates are solutions to the equation. You can use the x and y intercepts as 2 of your 3 points, right? So find the intercepts and then find a third point to ensure accuracy, right? And make sure the points line up when drawing the line. This method is often the quickest way to graph a line, all right? So here's what they're saying. Kind of the same question I had before. I want to graph this line. I have negative x is plus 2y is equal to 6. But what I want to do now is I want to actually just find the intercepts. And then from that, I'll be able to graph it. Maybe I find one more point and then that's it. So let's plug in 0 for x, right? So x equals 0. I'm going to plug in 0 for x. This becomes negative times 0 plus 2y is equal to 6. This becomes what? 2y is equal to 6. Divide by 2, divide by 2. Y is equal to 3. This is my y-intercept. All right? So when x was 0, y became 3, right? Y-intercept. Let's find the x-intercept. So y equals 0. So this is going to become negative x, right? Plus 2 times 0 equals 6, which becomes negative x. Sorry. Plus 0 is equal to 6. Negative x is equal to 6. And then divide by negative 1. X equals negative 6. So negative 6 comma 0. That's my second point, right? And then we could just pick one more point just to call it a day, right? I'm thinking maybe 2, positive 2. You could pick whatever third point you want. It don't matter. I'm just picking positive 2. So when x is 2, what do I have? I have negative 2 plus 2y is equal to 6. I'm going to add 2 over here. We do to one side, do to the other. So I have 2y is equal to 8. Divide by 2, divide by 2. I have y is equal to 4. And there you go. That's my third point. So the third point is on you, but the initial, right, the x-intercept, the y-intercept, you just plug in 0 for the x to get the y-intercept, plug in 0 for the y to get the x-intercept. And now we're back to square one. Plot the points, connect the dots. That's the end of the conversation, right? So this goes out to 6. So this is going to be a big graph. I'm going to have to scroll down a little bit because I don't think I can fit all of that. Let's try this. This is 1, 2, 3, 4, 5, 6. So I'm going to try and do 7. So this is -1, -2, -3, -4, -5, and -6, right? And then this is -1, -2, -3, -4, -5, -6. And this is what? This is 1. Wait, always doing that. 1, 2, 3, 4, 5. Sorry about that. 6. Okay. Let me get my points real quick. I have x, y. I have 0, 3, -6, 0, and 2, 4. Let's plot these points. 0, 3. So go to 0, go up to 3. There we go. -6, 0. Here we go. And then +2, 4. There we go. All right. Those are 3 points. Make a line that goes through them. I forgot to label them. Right. So this is 3, 0. No, I'm sorry. 0, comma 3. This is 2, comma 4. And then this one is the -6, comma 0. And that's it. Questions on this?
We covered.
I picked it. I just picked 2. You can pick whatever number you want for the third value. Doesn't matter.
So, so. Wait, so that X 0. You break down.
That's the X, that's the Y-intercept for X0, and then this one is the X-intercept.
So what do you mean? That bar.
Which Y?
Now, why is you?
So I'm plugging in 0 for Y. So that means that this becomes 0. So it's -X plus 0 equals 6. Then I divide by -1 to get 6 by itself, which give me -6. Yeah, -6. I did write that. Okay. Yeah.
Why does we chose that?
No, that was automatic. So for X-intercepts and Y-intercepts, they're gonna have zeros all the time. Right? But for the random choice, whatever you want. No pressure. I guess a hint that I could tell you about, if you see a variable that's in front of Y, let that be your X variable. That'll make it easier. Positive or negative, your choice. Doesn't matter which one you want to choose. Mm-hmm. Right.
Then the Y, that would be gone. We change that, so we put it on.
Right. That's the Y-intercept.
We did the same thing with.
Yes. Mm-hmm.
And then for the last third column, you
Just chose anything. Yeah. Yeah. I mean, all right, I'll be honest with you. The reason why I chose 2, you see how Y has a 2 in front? That's the reason why I chose 2. And I would have chose either that 2 or I would have chose -2. Same thing to me. Makes no difference. You could choose 1. Absolutely. Yeah. The reason why I'm not choosing 1 though, right? Remember what I told you about the whole denominator thing earlier, right? That number that's in front of Y becomes the denominator. That's the reason why. Yeah. How did the X equal to? I picked it, right? But the reason why I picked it was because the number that's in front of the Y in the equation is 2. So, and then a random choice, whatever you want. Yeah. Oh yeah, most definitely. Oh, you know what I forgot to do? Hold up. I forgot to put the arrows here to make it go out. And the name of this is the X-axis and this is the Y-axis. Sorry about that. So what do you think? You guys feel like you get this? All right. So long story short, I'm plugging in 0 for X for one of my points, plugging in 0 for Y for another one of my points, and then do the denominator thing that I told you, right? Your choice of which one you want, negative or positive. No pressure. All right. Yeah, got you. Fabrice, I'm gonna ask you to do me a favor. During the lunch break, go check Low Hall for me, and then if you could like text me if they have stuff or not. Like, remember the microwave stuff? I want to know if they have any today. Yeah, like, I want to share it with everybody, let them know. Yeah.
It's like 2 years ago lesson.
Just
Okay.
talking about that.
Okay.
I figured out what I wanted to put it in words. So you have like this, you would want to cancel out this first, right?
Yeah.
You can't multiply all this by 2H. Right?
Absolutely.
You can't.
Yeah. Not by 2H.
What does it be by
It
two?
would be like 2 over H.
2 over H?
Yeah. Because remember, I want to multiply this by something that's gonna cancel it out.
Oh,
So
yeah.
the 2 on top, H on the bottom, and what you do to one side, you do to the other. That's legal.
But it would apply to the whole equation, right?
Right. Or like the whole left side of the equal sign and the whole right side of the equal sign.
And then
Yeah.
once you get to like somewhere down here,
Got you.
in the problem,
Uh-huh.
you have to divide by you divide by H to get rid of this.
Yeah.
Let's say I had like plus B, it would be the whole thing would be under H, or would it?
The whole thing would be under H.
Mhm.
So this is right. And then I forget which one you have to solve for, but just subtract the other one over.
Mhm.
That's it. Yeah.
But basically, when you're doing this,
Mhm.
say like I'm just gonna start making up. Say I have
Okay.
like I don't even know, something crazy like this.
Mhm.
You're gonna just the way you do it, like in order of operations, is you're taking away the leftmost number
Right.
until you get to the thing, until you get to your,
Exactly.
like, say if you were looking for like something like this, then you would.
You just keep moving everything else over because I want that numbered variable, whatever, by itself.
Yeah, but what would happen when you get to the point where you have like Oh, when you get to the division of division of division, you would start to.
Just divide everything out. Yeah,
Yeah, okay.
yeah. You're welcome. All right, let me give y'all some notes real quick. So this is how to graph a linear equation using the intercepts, right? Step one, you want to find the x and the y intercepts of the line, right? So you're gonna plug in y equals 0 to solve for x. That's gonna be your x-intercept. You're gonna plug in x equals 0 to solve for y. That's gonna be your y-intercept. Step two, you want to find a third solution to the equation. My recommendation, the denominator, right? Whatever the denominator is, positive or negative, your choice. Or do both if you want to do 4 points. It doesn't matter. Then you want to plot 3 points, right? And you want to check, right? You want to check that they line up. All right. And after that, you just connect the dots with the line, and that's the end of it. I feel like we get it. Do y'all want to see another one, or could I move on? Yeah. Y'all good? All right, let's move on then. So the last example I want to talk to you guys about, not the last thing, but the last example. So when the line passes through the origin, 0, 0, right? The x and the y intercepts are the same point. All right. So check this out. Check this out. Check this out. All right. Bam. So you already know what I'm gonna do, right? Make a table of values right here. You already know what my favorite points are, right? This is gonna be -1, 0, and 1, right? Plug them in, right? So we're gonna have for -1, this is gonna be -5, 0, 0, and 1 is gonna be +5. Did I lose anybody? I went kind of quick there. You guys understood what I did? All right. So another thing, right? Just to address what we were talking about earlier, right? If you think about it, this is whole number 5, right? You remember you could write a whole number as the numerator divided by 1, hence why I'm choosing -1, +1, right?
There's no P, it's just.
Right.
0, 0.
Exactly, exactly. So that's the point of this one. So if I'm gonna graph this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I'm just going kind of quick with this because I want to do another topic. So this is going to be -1, -5. Here we go. Then we have 0, 0 to origin. And then we have 1, 5 right here. All right. Remember to label your points. This is going to be the point -1, -5. That's 0, 0. That's 1, 5. Connect the dots using a line all the way over there. So this is the line, where should I write it? Right here, y equals 5x. All right. And I forgot to put these there. X-axis, y-axis, okay. And that's it in a nutshell. Any questions on this? Go ahead.
How did you choose that?
Oh, no, I plugged it in. So let me see. Y of -1, for example, this is gonna be 5 times -1, so -5. And then y of 0, this is 5 times 0. I'm just using the equation that we were given up here, right? That's just 0. And then y of 1, this is just 5 times 1. This is 5. So that's how I got the points right there. Just plug it into the original equation that you were given, y equals 5x, and you're good to go. All right?
Oh, yeah.
Yeah,
All right.
yeah. All right. Y'all need to try one or we can move on? You wanna try one? All right.
You guys have it.
Yeah. There you go. Try that out. Oh yeah, sure. Oh, my fault. I'm sorry. I thought you were done. Let me know when you finish. Yeah. For the one that they're trying for that everybody's trying is y equals 4x. So during the break, I'm gonna get you guys the practice sheet. All right. Just like we've been doing. And I'm gonna come up also with the review thing, like what we're gonna do here. Okay. The review that I'm gonna come up with, I'm gonna try and I'm gonna make it a little bit simple. The reason being that time is against us, we only have like 2 hours after the break to work on stuff, and I don't want to keep y'all beyond your time, you know?
So I don't need that one, but.
I don't know. I don't make the test, so I don't know. Yeah. But I got y'all. I'm gonna give y'all a review. We're gonna look at that. You guys have the practice questions, right? I gave y'all like that's gold. That's all y'all need right there. You know, anything that they're gonna throw at you is gonna come from those packets right there that I'm giving out to y'all. You know, but which specific one? I don't know. Like you mean the testing out? It's it's just to help you out. Instead of you having to go to the 28.5 with the remedial, you get to go to regular 28, and then it's easier, you know, because when you do 28.5, it's like 3 days a week. It's really long. It's a lot of homework, like it's a lot of work, but the regular 28 is not so bad. This is the beginning of 28.5. Yeah. So you test out of this and you're good to go. Like next semester will be a breeze.
So you can go keep walking.
Not the whole, oh, you're skipping majority of the other class. Yeah.
Kind of like,
Yeah.
so, I mean, 4 times.
Yeah. Yeah. Yeah.
4 times a week.
Mhm. Well, look, the secret to all of this, right? Just do the homework, and go to tutoring. That's another thing. Like we have tutoring available. Go to tutoring like throughout the semester. You don't have to go to tutoring with the question. You can literally just go to tutoring to do your homework. You know? Like sometimes it's nice to have someone sitting beside you while you're doing your homework. And if there's a question, you can ask them. Otherwise you just relax there, just do your homework in peace. If a question comes to your mind, you ask it. If not, you just keep going, and then when you're done, you're done. You know? So I didn't even got tell you guys this, but I'm actually alumni to BCC. Like I graduated from here. And when I was a student, that's how I used to do my math. Like I would go straight to the tutoring lab only to do my homework. Most times I didn't even have a question for a tutor, but if I needed to ask a question, it was real easy for me to just go over and say, "Hey, can you take a look at this? What do you think?" It's pretty cool. I am. Yeah.
Wait, so you work for BCC?
Mhm.
And semester start with the government, but
I am. Yeah. All right.
why? They do.
Not the Y, the X. Yeah, choose for X, whatever you want.
I don't know. I think they're going negative.
Those are my favorite. All right, we good? All right, let's take a look. So I want to make a table of values, right? I'm gonna plug in some numbers. You already know my favorite. -1, 0, and 1. And then let's see. -1 times this is -4. 0 times that is 0. 1 times this is 4. We on the same page? Okay. So now I'm just gonna go straight to the graph. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I want -1, -4. So come across the -1, go down to -4. There, I'm sorry, hold on one second. Okay, here. Then I have 0, 0, the origin. Then I have 1, comma 4. Literally the same graph as before, right? So this is -1, comma -4. This is 0, 0. And this is 1, comma 4. All right. X-axis, excuse me, Y-axis, X-axis, sorry about that. And then let's connect these dots. It's gonna go like this. That's good. And this is the equation y equals 4x. Good to go, right? All right, new topic. New topic. But before we jump into that, I just want to do a little blast from the past real quick. So I want to evaluate 3x minus 5 when x is equal to -2. Remind me how to do this again? Exactly, right? So this becomes 3 times -2 minus 5, right? Which becomes what? -6 minus 5, which is perfect. Well done. That's it. All right. Questions on this? Anybody? All right, let's try another one. Let me see if y'all gonna get this one though. This is a little bit harder. We never talked about this before. So I want to evaluate 2x squared minus x minus 3 when x is equal to a. Tell me what to do. No, a is what I want you to plug in. Tell me what to write. No. I'm not plugging in a number for a. A is what I want you to plug in. Okay. Uh-huh. What else? Perfect. That's the whole answer. You're done. Well done. All right. Ah, that's it. Just plug in A. Any questions on this? Mm-hmm. Yeah. Right. There's no number to solve. Just change the variable. Mhm. Yeah. All right, let's get another one. Oh, everything is in here in this building. Yeah. Not all the class, like for the summer, yeah, but in the semester you might have classes all over the place. Yeah. Maybe. Yeah. Some classes meet in other buildings and stuff like that, but for the summer, yes, we'll all be in this building. Help me to do this. I want to simplify this. I have 7x minus 1 minus 4x plus 5. Right. So tell me the answer. Uh-huh. Uh-huh. Keep going. Mm-hmm. What is that? 4, right? So 3x plus 4. That's my answer. Mhm. Oh, that's it. That's all you had to do. All right. Simplify the expression. Questions on this, anybody? Good? Nope, nothing else to do. There's no equal sign. Yeah, I'm just trying to simplify it. Yeah. Justin, you good? Yeah. All right, man. All right. So look, this is what we're about to get into. It's a new idea, even though you kind of saw me do it already. All right. This is what you were asking about earlier. So a function, right? So a function is a relation that assigns to each element in its domain exactly one element in the range, right? That's some big vocabulary words. Long story short, whatever I give you for x, you plug into the equation and give me the answer. That's all that means. All right? So in algebra, more often than not, functions will be represented by an equation. It is easiest to see if the equation is a function when it is solved for y, right? If each value of x results in only one value of y, then the equation defines a function, all right? Blah, blah, blah. If you can solve for y, if you can get y equals something, that's a function, period. Right? Now let me clarify my English a little bit, right? If you can get y to equal something, it's a function, not some things, right? If you have multiples, that's not a function. All right? Just so we're clear, just so we're clear. Huh? Like what it is? So anytime you see me have something like y equals 2x plus 3 function, right? Like so basically I want to be able to solve for y in whatever equation I give you.
So you like I.
Yes, that's a function, right? If I have multiple y's, it's not a function,
Only gotta be
right?
one.
One y, right? So let me show you an example real quick. So in this example, right, we want to determine if each of these equations is a function, and we're going to assume that x is the independent variable, all right? X is what you plug in, right? Long story short, let's look at A. A says 2x plus y is equal to 7, right? Can I solve for y? Right? Yes, right? So let's solve for y. Tell me what to do. Subtract the 2x, right? To get rid of it. And what you do to one side, you have to do to the other. So now what do I have? Y equals negative 2x plus 7. I got y by itself. I can get y by itself. So yes, this is in fact a function, right?
Oh, wait,
Uh-huh.
so it's determined by a function once it's simplified fully.
Yeah. If you can solve for y. Let's look at B. B says y equals x squared plus 1, right? Can I solve for y in this? Right. So yes, this is a function.
You would also say the thing,
Mm-hmm.
we just have to different.
Let's talk about C. I have to get another color. Let's do purple, right? C. I have x plus y squared is equal to 3, right? Can I solve for y here? All right, let's solve for y. Tell me what to do. Very good. You're going to subtract x from both sides. So now I have y squared is equal to negative x plus 3. What do I do after that?
Divide by y squared.
Not divide by y squared. I have to get rid of the square. It's all right. You'll learn that later on in the course. But here's the thing, right? Y squared, what does that mean? That means y times y, right? That's two y's. I can't have two y's. I can only have one y. This is not a function.
But if you went like y plus y, would you simplify that and then?
So y plus y, you factor, wait, that's 2y. Yeah, that's fine. Yeah, y plus y is 2y. So you divide by 2 and that's it. That's good. Yeah. But y squared is an issue. That's not cool. Yeah.
Yeah, no, that,
Yeah.
yeah, multiplication too, nothing.
Yeah, that's fine. Well, multiplication could lead to this. So y times y will give you y squared.
Y, y somehow.
2y times y squared. No. Yeah, that wouldn't be it. Let me let you guys try one because this is a new concept. Okay.
So, three is not, does it have why?
It has two y's. It's as simple as that. Yeah. Three would actually be okay, believe it or not. But we're not gonna get into that right now. Try this. In all three of these, long story short, can you solve for y? If the answer is yes, we're good. All right. If the answer is no, then it's not a function. More specifically, can you solve for one y? Just one of them.
Oh, I got 7 first one.
7x? No.
That is one.
Can you solve for y?
I, that's,
No, that's not good. Yeah. You can't combine 3 and 4. They're different. All right. One one is 4x and the other one is -3. Right? Those are different terms. Those are not like terms. Only like terms you can add together.
So then we create X, Jenkins subchild, like -1X, so -3X.
If there was an X on the 3, yes. But there's no X on the 3. Yeah.
I'll be, I'll be that.
It's a function if you could get y equals something. If you can't get y by itself, like y equals something, like if you have something like y squared equals something, that's not a function.
Like, minus three,
Mhm.
so it's not.
Mhm. Let's talk about it. Let's talk about it. So for A, all right, I have 4x plus y equals -3. All I'm trying to do is solve for y. Just solve for y. So to solve for y, we subtract 4x from over here. What you do to one side, you have to do to the other. So now what do you have? You have y equals negative 4x minus 3, right? Is there one y here? Yes, so this is a function. How about b? So for b, I have x plus y squared is equal to 1. Help me solve for y. What should I do?
I mean, you missed that.
Minus x, very good. And what you do to one side, you do to the other. So now I have y squared is equal to negative x plus 1. Is this a function? No, not a function.
Wait, so how does negative three gonna negative four,
How does negative what? No, because they're different. They're different terms. So negative 4x, right? That's its own term, and negative 3 is its own term. It's because of the x that's next to it, right? 3 would have to have an x next to it for me to be able to combine them. But because it doesn't, they stay separate. Negative 3, negative 4, yeah. Mm-hmm. All right, how about C? I have y minus x squared is equal to 2. All right. Can you help me solve for y? Good. I'm gonna add x squared here. What I do to one side, I have to do to the other. So now I have y is equal to x squared plus 2. Is this a function? Yes, it is a function. Very good. And that's it. Huh? All right. Very good. Very good.
why
Which one? A, B, or C?
B?
B. So you see how it's y squared? Because of that, right? I can't have multiple y values. I can only have one y value in a function. Okay. Or, no, that's right.
Like B has the second the term.
Say it again?
B has the second term.
Yeah, that's its own term. It can't be combined with the two. I'm sorry?
Why? So. Yeah. We had that big on negative things where so I think so. Whatever we think of this and accidents. Plus square most of that way. It's so that way because y is on y squared or something like that.
So I just want to build a little vocabulary real quick before we jump into anything more complex. All right. So the next idea that we're going to wrap our heads around is finding the value of a function, right? So it is very convenient to name a function, and most often we name it as f, g, h, or capital F, capital G, or capital H, right? In any function, for each x value from the domain, we get a corresponding y value in the range. For the function f, we write this range value y as f of x, right? So this is called function notation and is read as f of x or the value of f at x, right? In this case, the parentheses does not indicate multiplication, right? It's not multiplication, it's what you're going to plug into the equation, right? Let's talk about function notation, all right? Yeah, this is notes, yeah. So function notation. So for a function y equals f of x, f is the name of the function, x is the domain value, the number that you're gonna plug into the equation. F of x is the range value of y corresponding to the value of x. So we read f of x as f of x or the value of f at x, right? And sometimes you might hear this referred to as domain and range. So we call the x, right, value, right, the independent variable, as it can be any value in the domain. And we call the y the dependent variable, as its value depends on what x is. All right. Let me pull this down so you can see better. There you go. Real quick, let me just show y'all what I'm trying to describe here, right? Even though we've been doing it already, I just want to elaborate. So if I have a function f of x is equal to 4x minus 5, and then I say let x equal 2, then that means that I'm asking what is f of 2? So what you're going to do is take the 2 and plug it into the equation. So 4 times 2 minus 5, which becomes what? 8 minus 5, which is 3. So f of 2 is equal to 3. Questions on that? This makes sense? I know we kind of been doing a little bit of this, but now I'm like formally defining it for you. All right. So that being said, this is what's going to happen, right? I'm going to give you a function, whatever that function is. I'm going to give you some values that I want you to plug into that function, and you're going to tell me back the answer. That's it. Yeah, yeah, sure. Right here? Yeah, 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 go ahead. No problem. I am aware of the time. Just give me two more examples, and then you guys can go get your lunch, and I'll give you back the time so we can meet at a later time as well. Then I'm gonna get you your practice questions and come up with something in that space of time.
Yeah,
I'm sorry?
that's all that,
Oh, no, no, I did that already. Yeah, see? It's just the idea, like you're gonna plug in the two for that, and then you're good to go. You good?
Okay.
Alright.
But for the bottom of the next part.
Oh, I'm sorry. This part right here? Yeah. Sorry, let me just do two examples and then I'll let y'all go for your lunch. But you guys could pretty much do this already, you know? Sorry, let's kill two birds with one stone. Tell me what to do. Right? F of x is equal to 2x squared plus 3x minus 1, right? Help me out. What is f of 3? Tell me what to write. 2 times 3 to the second power, right? Plus 3 times 3, very good. Minus 1, right? So now let's answer it. 3 squared we know is 9, so this is 2 times 9 plus 3 times 3 minus 1. Let's do our multiplication. 2 times 9 is what? 18 plus 9 minus 1. And you just do the math on that, right? What is that? I think is it? Yeah. 27 minus 1, yeah, so 26, yeah. Questions on this? Anybody? Hmm? I'm literally just plugging it in. That's all I'm doing. Nothing fancy here. Mhm. How about B? B is f of negative 2. Tell me what to write. 2. Perfect.
We,
Mm-hmm. Perfect. Minus 1. Perfect. That's well done. That's well done. So let's do the math on that. So this becomes 2 times negative 2 squared is 4 plus 3 times negative 2 minus 1. I'm sorry, go ahead.
What's the, so say if you had this problem on test, how would you, write the answers? How would you like that, X equals 26 for A, like, right,
Like the same way that I'm writing it here.
just equals 26.
Yeah,
That's it.
yeah. Oh, I'm saying, I understand what you're saying. Like if you want to, if you have to do like this, yeah, that's fine. I would take that. That's not bad. Yeah. Because you see how the equal sign keeps coming down? That means that it's like associated with that answer, f of 3. Yeah. Where'd you get lost? This 2 right here? F of 3 is what they're asking me. The 2 is from here. So I'm replacing x with 3. That's why. Right? So I'm plugging it in. I'm replacing x with 3. So whatever, you know how you say f of x? Whatever is here in the x, that's what's gonna go here. Right. X is the 3. So continuing on the other one, it is there. It just says 3. Yeah. I'm replacing x with 3. And then I just do the math to solve for it. That's all. So 2 times 4 we see is 8. 3 times -2 is -6 minus 1. This is what? 2 minus 1. This is just +1. And that's it. Questions on this? Or it makes sense? Okay. Just plug it in. That's the secret. Just plug it in. What about part C? Part C says f of A. What is that? Hmm? No number, just A. Mhm. 3 separate examples, A, B, and C. Yeah.
Basically, just plug in for X.
Exactly. That's it. All right. Tell me what to write. 2. Good.
Uh,
Uh-huh. Perfect. That's it. That's the answer.
If you could condense it further.
If I could, but I can't. Yeah. Yeah. So just this example, is there any questions on this? Does it make sense? I'm just plugging in the value of x. That's all I'm doing. Just plug it in. Mhm. Good? Yes. That's the original function. If they do, then that the equation will have g's in it. That's all. Yeah. Later on, you're going to learn something called composition of functions, where they do plug in a function into a function. We're not doing that here, but just let you know about that.
So F is basically just stating that like this is a function problem, and then X is just saying that. And because it's a problem, it's going to be a range of values for this variable.
Right.
And then F parentheses X
Mhm.
is just saying that this will be a range of values that we'll use.
Exactly. Yeah. So f of x is like your y value, your answer. And then x itself is what you're plugging in.
It's just synonymous with the definition of the variable, but just saying
Right.
this will be a function problem.
Right.
Or just for different definition.
Right. It's a new notation. That's it. I'm sorry? Exactly. Go ahead.
Can you not say 2A plus 3?
No, they're not the same. That's 2a squared. And then that's 3a. That's two different terms. Then, yes. Yeah. Then, yeah. But speaking of that, let's look at this next example. All right, different example here. So I have this function g of x is equal to 3x minus 5, and I want to find a, b, and c. I want to find g of h squared, g of x plus 2, and I want to find g of x plus g of 2. Let's go through these step by step. All right, let's go through these step by step. So I'll keep the purple, right? The first question asks me, what is g of h squared, right? So literally, I'm going to take h squared and plug it into the equation, right? So this is going to become what? 3 times h squared minus 5. That's it. Drop the parentheses, this becomes 3h squared minus 5. All right, any questions on that?
Like that.
It don't. It don't. And this is the original equation up here. This made sense? This was a little complicated. Go ahead. Exactly. Go ahead. Oh, yeah. So literally just replace the variable x with h squared and we're good to go. All right. All right, let's take it up a notch. All right. This next one is going to be special. All right. Matter of fact, I'm gonna do this one in colors because I want y'all to get it. All right. So this is g of x plus 2 is equal to 3 times the x plus 2, right? Minus 5. Okay. Did I lose anybody? I'm doing B, by the way. That's what I was given. So my original function was g of x is equal to 3x minus 5. And for part B, they're asking me to plug in or find, excuse me, g of x plus 2. So I'm literally plugging in for x plus 2. This makes sense? Whatever's in the parentheses, I'm plugging in. All right? No, that's not the final answer, right? The final answer is I have to distribute this and then combine like terms, right? So what does this become? This is going to become 3x plus 6 minus 5. And then I combine like terms to get 3x plus 1. This is your final answer. Questions on this? Anyone? That I did. Yeah, the 6 minus 5. Yeah, that's the like term. This makes sense? Good. All right. I want y'all to pay attention to this next one. This next one is really, really complicated. All right, it's the hardest one out of all of them. All right. So I'm looking at part C. Part C says, what is g of x plus g of 2? Right? Let me write that down real quick. They want to know what is g of x plus g of 2, right? Now, this is literally what they're asking you, right? What is g of x? We have it right here. G of x is 3x minus 5. that's what you write down, all right? G of X is 3X minus 5, right? Matter of fact, hold on, let me do it like this. They want G of X plus G of 2. G of X we know is 3X minus 5, right? From the original equation, right? Bring down that plus sign, right? It's the same plus sign. Now, what is G of 2, right? So G of 2 is literally 3 times 2 minus 5. But here's the kicker. Put it in parentheses. Well, actually, wait, no, I don't need that because it's addition. The subtraction, I would do that, all right? But that's it. After that, do a little bit of math, combine like terms, and we're done with the question. 3 times 2, very good. So now I have 3x minus 5 plus 3 times 2 is 6 minus 5. And what would I do after that? Combine like terms. And what do I get when I combine like terms? Okay, 1, I got you. So this is 3x plus 1 minus 5. And what else? Combine like terms. So give me the answer.
Yeah.
3x minus 4. That's excellent. That's the answer. Right? So this one is a little complicated, like I was saying, right? Because this one is g of x plus g of 2. So you have to take the original function and you have to take the function again, and this time plug in the inside value, which is 2, and then you got to combine like terms in the end to get the final answer. Mhm. All right. Mhm. Yeah, we have to distribute that number in the front and then solve for, we'll simplify it. Simplify it. That's the right word. Mhm.
Why is it
G of x times,
why did not give that e time?
because the question, this is what the question had. They want g of x plus g of 2. So that's why. Yeah. Yeah, that's just the way they asked it. Mhm. All right, so when you guys finish copying, you can start your break. Let's say 1:30, be back here. All right. Fabricio, you got my number?